Say cheese.
They wouldn't be able to do that.
Right. So 360, do you agree, is quite arbitrary? So the point of radians is to take that arbitrariness out of the picture, and it simply uses the radius to determine like the angles instead of degrees. Okay. Anyways, do you remember doing this?
Yes.
I thought I had given you these notes. Did you?
That was
Yeah,
it.
this we
I
did.
But only this page.
Only this page.
Okay. So anyways, we filled all this out.
Mm-hmm.
Do you want to go through it quickly again so you remember like how we came up with the whole like
Yeah.
how many
Look, our
degrees were in one radian and all that?
Yeah.
So what's the circumference of a circle? What's the circumference of a circle? Quick.
2 pi.
2 pi
r.
r. Very good. So how many radii? Look. How many radii are in a circumference?
2 pi.
2 pi, which is in decimal? About?
3.6.28.
Yes, it's double 3.14. So how many radians are in a circle? 2 pi radians.
2 pi r.
So if 360 is the equivalent of 2 pi radians, then 180 would be the equivalent of of pi radians. And then how do I get this to be a 1?
Pi
You
2.
divide by
Pi.
divided by pi, and then do this in your calculator, and it was approximately 57.3.
59.
57.
I want to say 57.3. 57.3.
Yeah.
So if you really, really want to know, this angle right here, 1 radian, this 1 radian, is about 57.3 degrees. Okay? No matter the size of the circle, as big or as small as the circle may be. And guys, and of these three, which one do we use as our unit of conversion?
180.
The middle one, why?
Because it's the.
It's exact. And even though the first row is exact 2, it uses bigger numbers when we don't have to. Yeah? And then we did this. So we're going to skip it because now you know how to convert degrees to radians, radians to degrees. You already have this.
We also did this.
Yes. So that's next. Yeah. So you just convert using the units of conversion pi to 180 or 180 to pi, depending on if you're converting degrees to radians or radians to degrees. Did you want to practice anything?
We did that? Like, pretty sure we did it.
We already did it.
We already did it. Great. And then this is the unit circle filled out, which we already went over as well.
And had a quiz on.
And ours is actually prettier, so we're good.
And
And we did this slide as well. So those of you that still have trouble remembering who's who, there you have it. Memorize it.
Memorize it.
Okay. Ah, finally.
No.
The new stuff.
You know, we can go back to the.
Okay, no, this is super easy. Do you know what a proportion is?
No.
Yes.
I mean, yes.
Like, give me an example of a
Big
proportion.
A piece of a whole.
Yeah.
Portion.
Would be like
Like when you're turning, like for example, like a number to a percentage. Like I don't know, I use proportions.
Yes. Give me an example.
This is to that and this is to that.
Give me an example with numbers.
So, 3 books cost $5. How many
Okay.
will...
3 books is to $5 as 6 books is
Is
to
what?
How many dollars? Yes, $10. Ta-da! That's a proportion.
But like
Nice.
Regla de 3.
Yes.
radiant, like.
Primera vez que lo usamos en esta
Y no es así.
No es
Uno hace la
así.
la toalla y ya está.
But that's all
Hace la línea y la línea. Aprende a escribir una regla de 3.
Okay, guys. Basically, yeah. Let's take the real life application out of it. Like 2 is to 3 as give me an equivalent.
3 is
That's
3 over 5.
Okay, as 4 is to 6. Give me more creative.
8 over 12. Okay,
More
16
creative.
over 36.
22 over 230.
And 5 over 6 is to 30. No, isn't it the same?
No, No, I disagree.
Okay.
I don't know.
why I
It's like
disagree.
never mind.
Whatever. You know you can multiply by anything you want.
Negative 66 over negative 99.
Okay. Yes.
Holy moly.
That is all equal to 2/3. You understand? All of these are called proportions. It's just equivalent fractions. That's all it is. Okay, ready? That's the only concept we're using today. Can you handle this
No.
concept?
Maybe.
Okay.
I don't promise.
So here we go.
Oh wait, too much.
Okay. So guys, arc, and you actually already came up with this, but watch, I'm gonna prove it to you using proportions. So we're gonna do two proofs. First for arc length, and then for area of sectors. Okay, I'm gonna prove to you these formulas and where they come from using the simple concept of proportions. Watch. Ready? Okay. You know what I mean by arc length? It's this little part of the circumference, that little curved part. But the length is if I were to snip, cut it out of the circle and stretch it out into a straight line, the length of that is what we call arc length. Good? So it's a portion of the whole circumference. So look, in these proportions, we're going to do part to whole. This is what like our ratio is going to come from. So the arc length is a part of the whole what? Circumference. As, and it's going to be in the same ratio as theta, that angle there, is to what? How many whole angles in a whole circle? 360. Yes, but I'm going to write it as 2 pi. You'll see why in a second. Is everybody okay with that proportion?
Yes.
Like, the ratio of this arc to the whole circumference is going to be in the same ratio as this angle is to the whole 2 pi? Yeah. Okay. And what was the formula for circumference again?
2 pi radius.
2 pi r. So go ahead and replace that for 2 pi r. And we're solving for what arc equals. So how do you solve for arc?
Cross multiply.
Multiply both sides by 2 pi. By 2 pi r. Sorry. Multiply by 2 pi r. Everybody okay? And what cancels?
The 2 pi.
So you're left with the fact that the arc length is equal to
Angle times
r theta. Do you guys remember coming up with this formula?
Yes.
No.
See.
You had like the biggest hope that we said yes.
No. Okay, look, I'll refresh your memory.
I'm sorry to.
I'm gonna see.
Look. When I first introduced you radius, you actually came up with it. Do you remember that?
Yeah.
Do you remember that?
Yes.
You came up. Look who that is. That's arc length. You came up with that by doing these little. Do you remember this?
Yes.
Okay. So now you have a formal proof. Now, guys, please understand. Would this have worked out had I put 360?
No.
So this only works. See, there's a little fine print. Only works if theta is in radians. What if theta is not in radians? What if they give you an angle that's 60 degrees? So you make it pi over 3.
Convert it.
Yes. And then you could use the formula.
May I ask you a question? Like, it's about arc length, but it's not for the IB, it's for the SAT. I remember the question that it was a circumference
degrees is to 360 as the arc is to the circumference, 2 pi, whatever the r is.
This means proportions.
And then you solve for arc.
No.
So instead of putting 2 pi here, you would put 360.
Easy.
It's a still proportion. It's part to whole.
Vix, a ti te enseñaron con. Yo no tengo ningún curso de ese tipo. No. A ti te no. Yo digo en general, en la escuela te enseñaron proportions, ¿no? Tipo, bueno.
Enseñaron regla de 3.
Ajá, regla de tres, es lo mismo. Fíjate que ella lo escribe diferente.
Exacto. Esto es regla de 3.
Do you understand?
Easy.
Like if this is 100, 100 is a part of the whole 360, as this arc is a part of the whole circumference, 2 pi r. Here I just made up r is 7. And then you solve for arc.
¿Por qué?
Regla de 3 goes boom, boom, boom.
No, but it's.
You multiply and you divide.
The way we write it is different, so like I understand it.
Yeah, you have to write it in a specific way.
Ajá, there's a specific way.
Tipo rayita.
Okay, guys. In a similar way, we're gonna prove the area of the sector formula, which is this. Do you see it here? This is also in your formula book. I'm just gonna prove it to you so you have an understanding of where it comes from. Okay. So you're gonna do proportions again, part to whole. For short, I'm gonna abbreviate area of sector, AOS. Area of sector. You understand?
Yes, we got it.
Yes.
So the area of the sector, which is the whole blue shaded region. You understand what I mean by area of sector?
Yeah.
It's like the area of a slice of a pizza. Yeah, like this whole area here. So the area of the sector is a part of the whole what? No circumference of the whole
Area.
area of a circle. What's the area of a circle?
It's like
That's
R
square.
squared.
No, they're not. They're round.
R squared. No.
Malísimo.
R squared.
You're waiting for a reaction of the joke.
No, because
Oh.
people don't get it. He just got it.
Oh my God. Squared.
Okay, let's try the joke again. What's the area of a circle?
Pi r square badum.
It's round. No, but you didn't finish the joke. You didn't finish the joke. Okay, I ask, what is the area of a circle? And you say pi r squared, and then I say, no, they're not, they're round.
Oh my god!
Guys, I don't care how cheesy you think that joke is. If it helps you remember the area of a circle, I don't care how cheesy it is. Pi r squared. No, they're not. They're round. That's how I remember.
That's
the area.
amazing.
No, she's talking about pies. She's talking about pies. Pies are not square. They're round.
But they're square pies.
Yeah.
I don't get it.
Pies
Pies is
are
Pies are not
Square.
Jesus Christ, I just got it.
No, it's a circle.
I thought you were laughing.
I always laugh.
I love myself.
Okay, ready?
Oh my god. No
Okay,
puedo.
let's continue.
Yeah.
Okay. Anyway, the area of the
Miss
sector
Gonzalez, you're not gonna get subscribers. We have to continue.
is to the whole area of the circle, as theta is to what? I don't want 360.
To buy.
I want to pi. Now I'm gonna solve for area of sector. That's what we're after. So multiply both sides by pi r squared. And then what cancels?
One, it would be
Pi.
like
Just the
one pi.
pies. So what are you left with? The area of sector is half theta times r squared. Do you see that formula up top? Ta-da! That's where it comes from. But again, guys, the little disclaimer is the same as that. Only if theta is in radians does that shortcut work. If not, you have to do the whole proportion with 360 degrees. Okay, let's try some.
Wait.
Oh, yeah, we're gonna skip this slide. I don't think we're gonna get to that today. Alright guys, so if you know the formulas, you could just plug in. So part A, if the central angle is 2.6 radians, that's great because it's already in radians. And the radius is 7, what is the length of the arc? So what's the formula? R equals R theta. R7 and theta is already in radians, 2.6. So you just do this in your calculator and you're done.
15.8. No, 16. 15. I don't need it later.
18.2 what? 18.2 what?
You should change
Centimeters.
it to radians because it's the
The
calculator.
radius.
No, Magdalena, you're multiplying numbers.
We're just doing arithmetic, so it doesn't matter. It's if we do sine or cosine of an angle. Then.
It's 18.2 centimeters.
Yes, guys, because it's just the arc length. It's just the length of something. You're in centimeters.
And how do you know it's like centimeters? Just the
Okay,
standard.
It says the radius
Ah,
is
okay.
7 centimeters. Part B, what's the area of the sector? So what was the formula again?
1 over 2.
Area of
Half-
sector.
half
R
times-
squared theta.
Theta.
Theta has to be in radians, which it is. So you just plug in R squared, and the central angle is still 2.6 radians. You just do that just do this in your calculator, and you get
R7. Y theta.
2.6.
63.7.
63.7 what? Because you just found an area of a sector.
Centimeters squared.
CM
Now you-
squared.
CM
Square.
square.
Centimeters squared.
Square.
Square centimeters.
And you judging how it is centimeters.
Okay, moving on. Yes? The thing went black.
It's okay, it's still recording.
Okay, I will draw a picture for what they're telling you because it helps to see it. So go ahead and draw a circle with a radius of 2.5 millimeters. It says find the central angle. So I don't know. So find theta if this arc, this is the arc they're telling you is 9 millimeters. So how do you find theta?
You use arc length.
Yep, you just use the same formula, arc equals r theta, right? Substitute it for what you know. You
So
know the
it's
arc this time is 9. You know the radius is 2.5, and you're trying to solve for
So
Theta.
it's 9 over 2.5.
9 over 2.5.
3.6.
I need 3.
3.6.
Oh, perfect. 3.6 what? No, that is not in degrees. That is radians. That's how many radii fit in
Radii.
9.
¿Cómo es? Radii. Radii.
Which makes sense, right? Because you're literally asking yourself how many of these radii fit into 9. 3.6 of them. Okay, next. Last slide. Oh, we're done. Okay.
Oh, yes.
Oh, this one gets a little harder, but that's fine.
I'm so hungry.
Okay.
Me too.
So guys, in this circle, they're saying the arc length here, AB, is 7.86 centimeters. So go ahead and label that in your picture.
It's really small. Tiny, tiny.
So tiny.
They're also telling you that the area of the sector AOB is 23.58 centimeters squared. So we're giving you the arc
And the area.
and the area of the sector. What do they want you to find?
Central angle
And
of the radius.
R. How many unknowns do you have?
2.
So how many equations do you need to
2.
find 2 unknowns? 2 equations. Where are the 2 equations going to come from? One from the arc equation and the other one from the area of the sector equation. And then how do you solve a system of equations? You do substitute. I'll probably go with substitution this time. But yeah, let's go arc equals r theta and area of sector equals half r squared theta. Those are the 2 equations we're going to be using. For arc, you're gonna substitute the 7.86 that they give you, and R you don't know, and theta you don't know.
Miss González, ya va.
I will pause.
You have to think about Daniela. You cannot go
She can always pause the video.
And slow it down.
because I'm like,
Ajá.
Okay, but you understand? They're given the arc, but you don't know R and you don't know theta, so you leave them.
Yeah.
Mhm.
Because I know where this is going and I'm going to use substitution, who should we solve? Like, should we already go and solve for a variable?
Yes.
You want to solve for R or theta? I don't
Theta.
R.
It doesn't matter.
R.
Fine. R it is.
Yeah.
Okay, so box that and leave it there for now. Now we go to the second equation, the area of the sector. And they're telling us the area of the sector is 23.5. And we don't know R,
Great, Adel.
and we don't know theta.
Theta.
I guess we should have solved for theta.
Oh, that's what I said because Ray. I hate you guys.
You can just substitute.
Yeah,
No,
now
but
we
then you
square
have
it.
to
It's
square-
fine. It's
square.
fine. Let's just go with it. Okay. So I don't know R and I don't know theta, but how can I use this boxed equation into this one? So now I can substitute. So substitute, and so you'll get one equation with just one variable. Ta-da! And then you just have to do this very carefully. Shall we do the algebra together?
23.58 entre 2.
No, I don't want. No, I don't want that.
Okay.
You mean times 2? Times 2. You want to get rid of this 2?
Yeah.
So times 2. You do 23.58 times 2.
58 times 2.
47.16.
We're getting rid of the half.
47.
47.16.
Can you square the 7.86
61.78.
Over.
over theta squared times theta? Did I lose anybody?
No.
So we multiplied by 2 to get rid of the half.
yeah.
And then we squared the 7.86 and we squared the theta. 1 theta on top cancels out with 1 theta on the bottom.
Mhm.
So you're just left with right?
Mhm.
And then what? You're trying to solve for theta. Multiply by theta and then divide by 47.16. And then
The good old
you get
1.310.
so like that. In what units? This is theta,
Radiant.
radians. And once you have theta, how do you get R?
Ay, la
Radiant.
puta.
Yeah, don't forget to put it back in here. 1.31. So R is
Let's eat you.
perfect 6.
6.
Wow, Marina.
Perfect.
6 what unit?
6 literal.
6 centimeters.
Centimeters. Alright guys, last problem. How much time we have? Oh my gosh, we have 2.
What is?
We have 3 minutes. Okay, we'll only get to one of them.
There's 2 circles.
This isn't your homework. I assigned this for homework. That's hard.
We have to get this.
That's hard.
Okay. 5 minutes. Yeah. Not much. Okay, guys. The question asks you to find the area of this little yellow shaded region. I know you don't have color, so it's the area of the little gray shaded region. Okay. Can you talk me through like a big picture plan of how to get that area? Just a big picture. Don't talk to me about numbers.
Find the area of the whole circle.
No.
No?
No,
It's
no.
a triangle.
Of the sector. This. And then once I get the area of that sector,
You
then
minus.
I subtract the triangle. Can we write that out? Look, find the area of the sector
You tried.
and then minus the area of the triangle. That's going to give me area of shaded a good idea for these complicated problems, and this one isn't that complicated, but wait till you get to this one.
Can we do that one with you?
No, because we don't have time in 5 minutes. It's gonna take longer.
We can.
So at least I'll give you it's basically this process twice.
Oh no.
Nice.
But anyways, for these like complicated problems, it's good to give like write out an outline of where you're going and then plug in the numbers. So now let's plug in the numbers. Wait. So for area of sector, now let's plug in the numbers. What's the formula?
Half
R
R squared.
Wait.
Times
R
the little
squared
the circle that
times theta. Yeah. And what's the area? Ooh, you don't know this.
Well, you can assume that it's 5, but you don't really know.
There's a formula. I'm just gonna tell. I'm just gonna tell you because that's the slide we skipped. It's a slide we skipped. But anyways,
Is it in the
it's this
homework?
formula. I wanted to prove it to you, but anyways, I'll prove it to you next time. But it's this, okay? So in a triangle, if this is your angle C, this is little a and little b. Like, do you know how you do you know how?
Yes.
The big letters are the angles, and then the sides opposite them are the little a, little b, little c.
So this bases off from the normal formula and just basically considers the angle that it has, right?
I will prove it to you next time. But yeah, you're basically replacing this
times the
is
height.
h.
Yeah, and you're considering the angle.
Yeah. So anyways, guys, I'm gonna just fast forward here because we're out of time. But the formula is half the two adjacent sides and the angle in the middle. So the two adjacent sides are 5 and 5, and then sine of the angle in the middle, 1.46. It's from the slide we skipped. Sorry. And please calculate these answers, and then you subtract them, and we're done.
18.25 is the area.
Okay, thanks. And the triangle? Oh, now it matters. You need to do this. You need your mode in radians in your calculator. Go to mode, change it to radians. And what do you get? Can I get a
No,
confirmation?
that's
Is your
only that.
mode- Is your mode in radians?
No, that's only that. Okay, now.
Then multiply it by 25 and divide by 2.
12.42. 12.4.
4, 2.
42. Yeah.
And now subtract them, and we're done.
5.83.
That is already in radians. Oh, this is just arithmetic. You're not doing sine or cosine of the angle, so it wouldn't matter in that case. And the answer is
5.83.
units. That's an area. So centimeters squared. Yes. Guys, all your homework is already on the Google Classroom. Okay. I'll see you tomorrow first period. Bye, Daniela.